Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting guide for DTC P24BB, which stands for Evaporative Emission Leak Check Module Pressure Sensor Circuit High Voltage. This diagnostic trouble code indicates an issue in the Evaporative Emission EVAP leak check module, particularly the pressure sensor's output voltage. A high voltage reading can signal a blockage in the drain hose of the EVAP leak check module, or problems with its related components. The Powertrain Control Module, or PCM, is responsible for monitoring various vehicle systems and will flag this DTC when it detects abnormal readings. Identifying the correct source of the problem is critical to ensuring the vehicle operates efficiently and within environmental standards. The DTC P24BB refers specifically to the EVAP system, which is fundamental in controlling fuel vapors and reducing emissions. Within this system, the EVAP leak check module, or ELCM, uses a pressure sensor that monitors the vapor pressure inside the fuel tank and evaporative emission system. If the pressure sensor outputs higher voltage than specified values, the PCM recognizes this discrepancy and logs the DTC. You'll find the ELCM integrated with the EVAP leak check module and the PCM located under the vehicle's dashboard or in the engine compartment, connected to various input and output circuits. Understanding the functionality and location of these components is essential for accurate troubleshooting. Several potential issues could trigger the DTC P24BB code. Firstly, a blockage in the drain hose of the EVAP leak check module can lead to abnormal sensor readings, as it prevents proper airflow and pressure regulation. Secondly, a faulty pressure sensor might directly cause higher voltage outputs, thus triggering the code. Additionally, there could be problems relating to wire integrity or connections within the circuit of the EVAP system. These wiring issues may incorporate open circuits, shorts, or damaged connectors that hinder normal operation. Properly diagnosing these aspects is crucial for effective repairs. With DTC P24BB, drivers might notice several symptoms indicating an underlying issue. The most immediate sign is the illumination of the check engine light on the dashboard, warning the driver of a malfunction that requires attention. Additionally, a malfunction in the EVAP system can lead to fuel vapor leaks, which could affect other components or result in increased emissions. Drivers may also experience poor engine performance due to an imbalance in the fuel-air mixture or reduced efficiency from the emission system. Being aware of these symptoms can prompt timely investigations before they escalate into more significant problems. The first step in troubleshooting DTC P24BB involves turning the vehicle to the on mode, ensuring all electrical systems are active without starting the engine. Next, use the Honda Diagnostic System, or HDS, to check the absolute pressure of the ELCM pressure sensor. If this value exceeds 899 millimeters of mercury, it indicates a potential glitch that duplicates the failure conditions specified by the DTC. It's essential to take a precise reading, as this helps establish whether the problem lies within the pressure sensor or potentially elsewhere. Thus, this preliminary check sets the stage for subsequent diagnostic steps. In the second troubleshooting step, you will need to inspect the EVAP leak check module's connector, specifically the 8P connector. Disconnect this connector to ensure a proper diagnostic environment. Subsequently, use a jumper wire to connect terminals 7 and 8 in the disconnected connector. After creating this bridge, turn the vehicle to the on position while monitoring the HDS system for readings of the absolute pressure of the ELCM pressure sensor. If the recorded pressure is less than 899 millimeters of mercury, the issue is likely within the EVAP leak check module. However, if readings exceed this threshold, It indicates other related component failures that must be further investigated. The third troubleshooting step involves performing an open wire inspection for critical components that could contribute to the P24BB code. First, ensure the EVAP leak check module connector remains disconnected, and then disconnect the PCM connector as well, specifically connectors E and A. With both connectors off, inspect VCC6, SG6, and ELCMPA for continuity. The normal condition indicates a resistance of less than 1 ohm. If the resistance is higher or the circuits are open, it suggests a wiring issue that must be rectified. These checks reveal important insights about the reliability of the connections, which are vital for the accurate functioning of the EVAP system. After completing the previous inspections and confirming that there are no faults in the associated components and wiring, the next step is to test the powertrain control module, or PCM, itself. If all other components tested normal, it is a strong indicator that the PCM may be defective. This module controls various engine parameters and manages the EVAP system's operation. Properly diagnosing the PCM can often require specialized equipment or professional services. A failed PCM can lead to a cascade of issues across multiple systems, making it crucial to assess its functionality as part of the troubleshooting process. After identifying and addressing the underlying issues with DTC P24BB, it's essential to perform a final verification to confirm the repairs were successful. Start by clearing the DTC from the PCM, which resets the engine's error codes. Next, recheck the entire EVAP system to ensure that all components are functioning as intended without triggering new codes. Finally, take the vehicle for a test drive to confirm that the system operates under actual conditions and that no symptoms persist. This step not only verifies proper repair, but also offers assurance that the vehicle will perform optimally. Preventive maintenance is critical to keeping the EVAP system efficiently running and avoiding future DTC codes like P24BB. Regularly inspect the entire EVAP system, including the leak check module and associated hoses for any signs of wear or blockages. Pay close attention to the drain hose, ensuring it remains clear of debris or obstructions that could cause pressure inconsistencies. It is also vital to keep all electrical connections clean and secure, as corrosion or debris can lead to intermittent signals and faulty readings. Implementing these maintenance practices will contribute greatly to the long-term reliability of your Honda CR-V. In conclusion, understanding the implications of DTC P24BB is crucial for both diagnosing and remedying the issues affecting the EVAP system. The symptoms, such as a check engine light and poor performance, serve as clear indicators that warrant further investigation. Following the outlined troubleshooting steps will guide you through diagnosing the code effectively, ensuring that all components are assessed systematically. Finally, incorporating preventive maintenance practices will help safeguard your vehicle against similar failures in the future, preserving both performance and emission standards. By being proactive, you can maintain the integrity of your Honda CR-V and avoid costly repairs down the line. Please like and subscribe to the channel. See you next time.